Awesome. So this talk will actually be very complementary to what Itai was just talking about. So I know we've been going over a lot of academic and deep diving, a lot of the protocol, efficiency, security stuff. This is more about applying MPC, what we gain from a user experience, security, and then what we can do from an account abstraction angle. You know, we've all been hearing ERC 4337 a lot, so hopefully we can see how these two technologies are actually complementary and not contradictory. So a quick background about myself. I'm one of the co-founders of Portal. I know she just mentioned NYU, but my alma mater is actually Berkeley, so go Bears. And I've worked in fintech companies such as Brex, Workday, data infrastructure companies such as Segment. I've had the privilege of working across various security functions such as security tooling and cloud security, and most recently incident response. And this way. Awesome. So today, I'm here to talk about basically how we can combine MPC with account abstraction to really unlock an amazing user experience, but also security for our users. And I want to mention, I'm a huge fan of sitcoms like The Office, Brooklyn Nine-Nine, Parks and Rec. There'll be a ton of their GIFs here, and throw me trivia questions at the end if you are also fans. I dare you. So what does adoption look like? And we started Portal with the mission to build infrastructure that enables the next wave. But what I mean by the next wave is the non-Web3 native users, and how do we enable our customers or businesses to enable their users to more easily and seamlessly interact with Web3. We have to, one of our core beliefs at Portal is that we need to bring the technology to the users, not expect them to change their behaviors to basically adopt Web3. And our goal is to basically abstract away blockchain so that people are using it without actually knowing what's going on under the hood. Like very similar to credit cards. I use my Visa card to buy a cup of coffee on my way in this morning, and I don't need to know what Visa is doing under the hood through all the settlement networks and everything. And this is an international transfer, right? So that's kind of what our core beliefs and what our goals are. And we need to kind of lay out what we mean by user expectations and like this mass adoption that gets thrown around a lot. The first bullet point, I don't even necessarily want to cover it because I know everybody agrees with that. But starting from the second one, forget password functionality. Users want to have that functionality so that, to err is human. You're going to lose your device. You're going to forget the password. You cannot expect users to tell them, hey, here's a secret. Keep this very secure. And by the way, if you lose it, I'm sorry, buddy, all your money is gone. Users also want familiar auth flows. This is something that Itai was just talking about in the previous talk. They want familiar auth flows from social login to username password to passkeys. They don't want to jump on a website and see a connect wallet button and get all confused about what's going to happen. Additionally, they want to have the trust that the platform they're using, the application they're using, is keeping them secure. When I got here to Singapore, I was trying to call a Grab, and my first transaction got declined by my bank because they were like, hey, this is anomalous, like, you need to come and confirm to us that you're actually there. Although a little annoying, I actually appreciate it personally. And lastly, users, they expect to use this blockchain Web3 technology in applications that they already have today. Imagine if your bank is like, hey, you want to receive and send crypto, go ahead and download a different app, completely different flow. Chances are users aren't going to be downloading that app. And there's Terry from Brooklyn Nine-Nine, when everybody's yelling his passwords around. Users don't want that. So how can we leverage MPC to achieve this? And a quick, highlight here. This is our setup at Portal. We have a two for two parallel shares. And I'm going to go through all the user expectations real quick of how we can actually achieve these with MPC. So in this case, we have a pair of signing shares. One sits on the user's device, the other one sits on our servers. And we also have a pair of backup shares. One sits in a cloud environment that is controlled by the user. In this case, it's G Drive. We know G Drive is not the best experience. I'm just doing this for the sake of argument. And so what happens when the user actually loses access to their device? Or maybe they forget the password to the application that they're using. Well, given that MPC uses reshare or refresh, depending on which protocol you're using, you can actually use the backup shares that is in the cloud environments to generate 2 new signing shares, therefore being able to recover your wallet. Next, let's talk about the anomalous behavior. Imagine if a request comes in from the user that says, hey, I want to sign this transaction. But the transaction is actually sending all the money out of the user's wallet. And also, this transaction is coming from an IP and a user agent that the user is not used to. Well, or not used to using. So what we can do when we have this type of setup is actually say, you know what? Pump the brakes. Let's verify that this is actually you. This looks quite fraudulent. And after you verify that this is you, the transaction could go through. Very similar to this email that I got, like I mentioned, from Citi telling me, hey, are you sure you're in Singapore trying to get this thing? Like, you need to verify this with us. Now, I know I mentioned 2 of the user expectations that I laid out earlier, but we can obviously build very nice custom authentication mechanisms on top of the DKG, and by just naturally distributing trust, we are removing the single point of failure. Therefore, leaked secrets like phishing, you're no longer giving away your private key. Now, where do MPC wallets fall short, right? That was fantastic. It looks like they're covering all of the expectations that a user has. But let me give you an organizational perspective. Imagine you're a gaming company and you notice that users, even though you're deployed on an L2, is very cheap, the gas fee is still a deterrent for your new users. And as this gaming company, you've implemented MPC wallets. Users hop onto your platform, sign up. They can recover, do all that great stuff. But they're still like, hey man, this is too expensive. I don't want to do all these transactions on your gaming platform. However, you recognize that if users, for those users that have been on your platform for multiple weeks and quite literally have skin in the game and have built avatars, they're not deterred by this gas fee. So you're like, you know what? Let me subsidize the first 100 transactions as a user incentive to bring on these users, to build enough avatars in the game so that they stay in. That doesn't really happen easily when you have MPC wallets. Additionally, let's say across all your users, you want to optimize gas by using transaction batching. Again, not very easily possible when you're using purely MPC wallets. Additionally, and this is not necessarily MPC specific, imagine if you want to use the iPhone's enclave signature mechanism. Well, the iPhone enclave is using the R1 curve, which is different than the K1 curve that Ethereum requires you to have. So you're kind of out of luck there if you have MPC set up. And so what do? We'll enter smart contracts and account abstraction. There they come in. All right, so just a quick highlight, like in 5 seconds. Smart contracts, pieces of code deployed on chain. Smart contract wallets, as their name suggests, are combining this programmable business logic at the transaction level with a wallet. So now that you're combining code with your wallet, what can you do? Well, you can set rules of how much money can be transferred out at once. You can set limits. You can set multiple different users to be able to send money out. You can put on custom authentication for your funds, and I'll mention that in a second what I mean. Additionally, with the addition of ERC-4337, it's very easy to be able to subsidize gas in a decentralized manner and optimize via transaction batching as well. Now, I want to call this out because I've heard this a lot, maybe not for the people in this room, but I've heard a lot that, hey, smart contracts, they don't have private keys. Therefore, if I use AA, I don't have to deal with keys, right? That's not true. The role of keys is to authenticate you as the owner of the wallet to be able to move funds out. So just, and the wallet or the funds are under the smart contract itself, but the owner is a public key of a public-private key pairing. And as soon as we're talking about keys and key management, we're going back to the same problem that we had before, which MPC is one of many solutions. But I do want to call out that even though there are no private keys for smart contracts themselves, there are still keys involved for authentication. And so smart contract wallets, they look great, everything's great. So what are the shortcomings? Well, you have to remember that because you have everything on chain now, every single action that you take with regards to your wallet will cost you money. So you want to add a new device. Let's say you're already logged in from your phone, but you want to add in your laptop. That's going to cost you money. You lose your phone and you want to add in a new device. Again, it's going to cost you money. Yep. So how can we bridge these two concepts between MPC and account abstraction to actually get even that, unlock that amazing user experience where both the organization that wants to subsidize gas is happy and also your user is able to recover in a very cheap way. So from the key management side, we bring in the no single point of failure. So if you're phished, you're not losing your private key, which has all the kind of access to remove your funds. You have off-chain recovery, so it doesn't cost you money to add new devices or generally forget your password. And then with this, you also have proactive security measures, so you can very easily refresh your keys and often in order, from a security perspective. And then from a smart contract side, well, the smart contract is now your fund manager, so you can use it for gas subsidization. I also want to call out, I forgot to mention, paying gas with ERC20 tokens. A Web2 user will see, hey, I have 10 USDC in my wallet, I want to send it out. But then the wallet is like, hey, you need to hold ETH to actually send $5. And they're like, wait, what? I don't want to send ETH, why is that involved? Well, that's because you need to pay gas in ETH. However, with ERC4337, you can start paying gas in ERC20 tokens. And additionally, the custom auth that I mentioned earlier, because now you have programmable logic, you can very easily build different signature verification mechanisms into your smart contract. So that R1 curve from your iPhone's enclave, now you can build a verification on-chain for that. There's actually a really cool project called Clave that is attempting to do this. And yeah, they're a fantastic team. And this is I was about to say quick, this is not a small or quick breakdown, but a chart of pros and cons of both. And as you can see, when it comes to both of them together, they do solve each other's cons in this context. And this is all of us because now, hey, we can offer a lot of different things to our users. And I want to show you guys what this looks like in action. Like Itai mentioned, I would not be a co-founder if I don't give a quick shout out to Portal as well. But at Portal, what does this look like? We can get there in 4 easy steps. First one, you initiate Portal, and then you generate a wallet. In this case, we've abstracted all of the I guess like thinking behind smart contract deployment and all that away. We've partnered with ZeroDev to do this, and you just run Portal MPC generate. The address that's returned is actually a smart contract address, and from a developer perspective, you don't need to worry about the storing of the wallet, or in this case, the shares in the keychain. All that happens under the hood. Second step, and this is an example for gas subsidization specifically, you can just hop onto our settings page, set how much you want to subsidize on what specific chain, and after that, you can just use the 1193 provider to send the transaction. And that experience looks nothing different than what you would be using if you were using, let's say, like Ethers.js. All you need to do is set up your transaction and send it, and gas subsidization actually happens under the hood. This is a 30-second demo. Oh, I guess not. But that demo was basically when you go through a very similar login on the phone, you just say, hey, you generate wallet, and then you send it. You
want to try again?
Oh, yeah, let's try one more time. Oh, nice. Okay. Good on time, or yeah, perfect. So in this case, for context, this is just a complete demo, like nothing more than that. And so you sign in with your email, very familiar auth flow in this case. You say agree, you generate the wallet. In this case, we're generating MPC and the smart contract. We're going to skip back up for this sake of the demo. In this case, I'm actually off screen funding my wallet to be able to send money out. After the wallet is funded, I'm going to paste an address that I'm going to send one way to. Again, this is all UI that can be customizable to anything. I'm making it very Web3-like with send one way and deploy contract button and stuff like that, but all of that can be abstracted away. And in a second here, we'll get the network will give us the thumbs up. And what we're going to get back is actually a user operation hash. User operations are what you can think of as replacements to transactions in ERC-4337. And if...
I think it has a lag, so you click it once and then just like wait.
Gotcha. I'm going to give 3, 2, 1. Oh, there we go. No, we're good. If you're like, hey man, you know, that was all whatever, just remember these 3 main things from this presentation is that users today, they want the Web 2.0 experience. They want the social login, the passkeys. They don't want to learn, what is a wallet? How do I connect it? How do I manage it? All that is out the door. But Web 3 is a powerful infrastructure that we can abstract away under the hood. Think about global settlements, right? That's something that Visa is doing with Solana that they mentioned. And so that second one, MPC and AA, they're actually complementary. Don't think of them as contradictory. A lot of people come up to us and are like, so what do you think about AA? Are they gonna, you know, take over and you're not gonna have MPC anymore and EOAs? That's not the case. In AA, you still have keys. There's many different ways to manage keys. There are different solutions. There's different problems that people are facing, whether from an organization perspective or an individual. And lastly, like I showed, you can actually combine these two together to get the secure key management from MPC and account abstraction for managing your funds, like batching and paying in ERC20 tokens. And lastly, that leads you to our docs page. If you're interested, goes to our account abstraction integration, and reach out if you have any questions. Think I am the last person, so we can just all have a cup of coffee, and if you have questions, we can just take it out there. But yeah, thank you all.
If you do have questions, we record all our sessions. So if you do have valid questions, feel free to also ask them. I see Dima already. And then yes, definitely, we will all break for coffee.
Thanks for the great talk. I have a quick question. So on the combination of MPC with AA, do you see a reason to keep using a non-MPC friendly curve or algorithm like ECDSA when you have the, as you mentioned, the control to use other authentication mechanism for that smart contract, and by thus kind of maybe reducing the attack surface, because we know that the ECDSA and MPC are more complicated, more chance for bugs, and so on?
Sorry, to clarify, you mean are there reasons to even keep ECDSA?
Yeah, I mean, like if you have basically you keep the, you can control the authentication on the AA level, like you said, so you could potentially use a different curve, like or use say EDDSA or something more MPC friendly.
Yeah, no, absolutely. I guess I would say you're not tied to using ECDSA. I think it varies based on use case. Like I mentioned, the project Clave, they're purely about how do we enable that iPhone enclave usage with smart contracts, especially because that brings like the Apple Pay functionality. But from the other perspective, like, no, I don't see a reason why we have to use ECDSA anymore in that sense.
Or I guess maybe the other way around, like if you can pick your algorithm for and still use MPC, would you even why should you even choose ECDSA as opposed to something where MPC is easier like EDDSA?
I see what you're saying. Yeah. I think in a practical sense right now, if you wanted to, let's say, verify an EDDSA signature on Ethereum with Solidity, you have to deploy a lot of different functions, right? So the setup itself is going to be quite expensive. And if I had to guess, the actual contract deployment and verification process becomes even more expensive because you're not using the native functionalities of EVM. So from a practical perspective, it would be more expensive to use it. But I think as it develops more, and I know there's even an EIP out to verify the R1 curve. Once those things go out, I don't necessarily see ECDSA being the thing that we all have to stick to, for sure.
Thank you.
Any more questions? Anyone want to ask anything about account abstraction?
Or Brooklyn 99?
Or Brooklyn Nine-Nine. I think
Parks
we've
and
come
Rec.
full spectrum because we started off with deep academia in our keynote, and we're ending off with the newest edge of the crypto space. So it's been a great 2 days. Thank you so much, Parsa.
Thank you. And thank you to the Silence Labs team for putting on this conference. You guys have done a fantastic job.
Thank you. Thank you, everyone. I won't bore you anymore.